This lesson is about right triangle trigonometry. So you've seen those buttons on your calculator that look like this. It says sin, cos, and tan. Well, we don't call them that. Those are just abbreviations for sine, cosine, and tangent. So first I'm going to give you the definitions, and then we're going to see what it looks like in our triangle. The sine of an angle. This is theta. It's a Greek letter, theta. It's just a variable that represents an angle. So it's like saying sine of x or sine of b or sine of whatever. So that's just a theta. The sine of an angle equals the opposite leg over the hypotenuse. The cosine of an angle is the adjacent leg over the hypotenuse. And the tangent of an angle is the opposite leg over the adjacent leg. And we'll see what those look like here in just a moment. Those are the basic definitions. And you'll hear people abbreviate it. They'll talk about SOHCAHTOA, because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you hear someone say SOHCAHTOA, that's what they're talking about. So here we go. I gave you this right triangle. We've got a triangle ABC. C is the right angle. So in this picture, every time we talk about the hypotenuse, we're always going to be referring to side AB, which is 13. That's the hypotenuse. The hypotenuse is always across from the right angle. Now, when we talk about the opposite leg or the adjacent leg, that's going to depend on which angle we're coming from. So let's say I started with angle A. From angle A, I've got the legs are 5 and 12. 5 is the leg opposite. 12 is the leg adjacent. So adjacent means right next to. So opposite all the way across, adjacent the one right next to. We always label the hypotenuse first because sometimes it can get confusing and you can say, well, look, the 13 is right next to the A. Why isn't that the adjacent side? Because it's a hypotenuse. We want the adjacent leg, so we identify the hypotenuse first, and then we just look at the other two legs and decide which one's opposite, which one's adjacent. So the sine of A, the opposite leg is 5, the hypotenuse is 13. The cosine of A, the adjacent leg is 12, and the hypotenuse is 13. The tangent of A, opposite leg, adjacent leg, 5 over 12. So that's all if we use angle A as our reference angle. Let's switch now and use angle B as our reference angle. If I want to know the sine of angle B, that's the opposite side over hypotenuse, 12 over 13. The cosine of B is the adjacent side, adjacent leg over the hypotenuse, so that's 5 over 13. And the tangent of B is opposite leg over adjacent leg, 12 over 5. And you might notice some similarities here. Notice that the sine of angle B is the same as the cosine of angle A. The sine of angle A is the same as the cosine of angle B. And then notice the tangents are just reciprocals of each other. All right, so how do we do this on our calculator? First of all, I would have you get your calculator and check your mode. Mode is the button right next to second. And if you scroll down a little bit, you'll notice this calculator is in radians. I need to be in degrees. Whenever we're doing right triangle trigonometry, we're talking about the angles in our triangles, we need to be in degrees. If at any time you do the old 2nd plus 712 to reset your calculator, you have just reset your mode to radians. We're going to learn about radians later. Use the radians a lot in pre-calculus, but for this we want to be in degrees. So check your mode and make sure you're in degrees, and then we can work. So the first question says, what's the tangent of 36 degrees? So I'm just going to type in tangent 36. And I think they asked us to round to the nearest thousandth. So that'll be 0.727. Because remember, thousandth that's our third decimal place. 0.727. All right, let's do sine of 44. So you literally just do sine of 44. You don't have to close the parentheses, but if you want to, you can. So this is 0.6946, so I'll go 695. 0.695. And then the cosine of 73, 0.292. Okay, so that's just warming us up on how to do this on our calculator. Now for number 4, I've given you the tangent, but I don't know what the angle is. So this is a special case where you're going to do the inverse function. Now to do the inverse function on your calculator, you hit the second button. So this says tangent of 0.5744, or the tangent is 0.5744. So what I'm going to do with my calculator is go second tangent, and it gives me that tan to the -1. That's the symbol for inverse, that -1 in between. And then just type 0.5744. And to the nearest degree, because that's what they said to do, to the nearest degree, it's 30 degrees. So when it says nearest degree, that means to the nearest whole number. Cosine of x. Second cosine, 0.7071. That's 45 degrees. And now we have this sine. So inverse sine of 0.2389. And that's 14 degrees. So you use the inverse function anytime you don't know the angle. So we'll just say looking for angle, you do the inverse. That's important to remember, so you can solve those questions. Now let's do a few examples at the bottom of this page. See how this works. So we take a look at the first picture. Here's the angle they gave us. That's our reference. This is the side we're looking for, and this is the side they gave us. So first thing I want to do in my triangle is to identify the hypotenuse. That's the one across from the right angle. Now that leaves me with two legs. One is the opposite leg and one is the adjacent leg. So you look at the 57. Over here, this is the opposite leg, which means that's the adjacent leg that they didn't give me any information on, so I'm not going to use that. So opposite hypotenuse. So this is where you're asking yourself, is this a job for sine, cosine, or tangent? Well, which one uses O and H? That's the sine. So I'm going to write my equation. It says sine 57, because you always take the sine, cosine, or tangent of the angle, equals opposite over hypotenuse. What I like to do is I put this one over 1 to make it look like a proportion. So then all I have to do is cross multiply. So in my calculator, I'm going to write down 23 times sine 57. I'm running out of space here. And I'll show you why I do that. 23 sine 57. The calculator will automatically multiply those, so you don't have to do it times. The reason I go this way is because if I type sine 57 first, if I accidentally forget to close off that parenthesis, it's not going to be right. So you'd have to do sine 57 parentheses times 23. So I just put the 23 first and then the sine 57 second, and I don't have to worry about whether or not I close off that parentheses. So 19.289. All right, let's look at number 8. 37 is our reference angle. There's x, and here's the 18. So that, remember, the first thing I always want to identify is where's my hypotenuse. That's the one they didn't give me any information on. So I need to use the trig ratio that involves everything except the hypotenuse. So from the 37, this is the opposite side. 18 is the adjacent side. So I look at my ratios, sine, cosine, or tangent. Opposite, adjacent. So this is a job for tangent. I'll write tangent 37 equals x over 18. So now I multiply by 18. 18, tangent 37, and I get 13.564. All right, next up, 43 is our reference angle. We identify the hypotenuse across from the right angle, and then we decide if this is opposite or adjacent. I'm going to go with opposite. So which one uses opposite and adjacent? It's a job for sine. So I'm going to write sine 43 equals opposite over adjacent. Now what do you notice about this one? I have my unknown value on the denominator. Well, that's different from the others. Here's why I always put the sine 43 over 1. Because when I have a variable on the denominator, now I can cross multiply. 4 times 1 is 4. X times sine 43. And then to solve for x, I divide both sides by sine 43. And I'll type that into my calculator. 4 divided by sine 43. 5.865. So it's important to remember, if you've got an x in the denominator, you're actually going to divide your number by sine whatever. See over here, when x was on the numerator, I multiplied 18 times tangent 37. But when x was on the denominator, I actually ended up dividing 4 divided by. So be careful with that. If your x is on the denominator, you have to take a slightly different approach to solving your equation. All right, now here's a few where they didn't tell us the angle. So these are the ones that require the inverse. Remember, if you're looking for the angle, you're going to use the inverse. But we still have to identify which inverse to use. So look at number 10. If I first identify my hypotenuse, and here's my reference angle, 50 is across, it's the opposite. 30 is right next to it. So I'll put adjacent. So now I'm looking for the ratio that only uses opposite and adjacent. And I believe this is a job for tangent. Tangent x equals opposite over adjacent. And I just plug it into my calculator. Whenever you don't know the angle, that's when you do second tangent. 50 over 30. And it'll do the inverse for you and tell you that's about 59 degrees. The directions told us that we can round all of our angles to the nearest degree and our sides to the nearest thousandth. So then we go to number 11. Here's my hypotenuse. That's my reference angle. Opposite over adjacent. So once again, this looks like a tangent question. Tangent x equals 18 over 11. From here, we plug it into the calculator. So you can see second tangent, 18 divided by 11. So to the nearest degree, that's a whole number, is 59 degrees. And then you can solve the rest of the triangle if you needed to. Number 12. Here's our reference angle. This is my hypotenuse. I forgot to put a box there. Go ahead and put that there. I meant to put one. That's my hypotenuse. And this one, remember opposite would be straight across, so adjacent is the one right next to it. And which one of our ratios uses adjacent and hypotenuse? I think it's right there, cosine. So this one's going to say cosine x equals 19 over 27. And then I can just take my calculator and do second cosine, 19 over 27, and get 45 degrees. All right, so that's the definitions of sine, cosine, and tangent. And I think on the back we get to apply it in some different ways. So I'll go ahead and do another video solving these questions so you can have some examples to look at.